Hi, are you able to hear me?
Yes, hi.
Great. So sorry, I think I'm a minute late. So let me just lay the outline of how the interview would go. So I'll give you a brief introduction about myself. I would like to hear briefly about what you're up to nowadays, and then we'll jump into the coding question. We will reserve approximately 45 minutes for for the coding question, and beyond that we can go through the feedback. Or if you have any feedback for me, I'm open to hearing that. So that's how we would go through this session. And as I talk with you, I'll also be taking some notes, which I so that I can consolidate my feedback at the end of the interview. Um, so that's it. Any questions on the process?
Yeah, I think I'm clear.
Oh, great. So,
Yeah.
okay, so I'll give you a brief introduction about myself. And yeah, of course, I have heard about audio issues on this platform. I haven't run into any so far, but if you are not able to hear me out, just let me know. If you want me to repeat something or clarify something, just let me know.
Yeah.
Um, Great. So I'll give you a brief introduction about myself. I have been in the software industry for 10 plus years. I have been working as a backend engineer primarily throughout, and focusing on Java and related technologies. And at present, I'm working for a media company. So yeah, so that's about me. Why don't you tell me something about yourself?
Yeah, absolutely. So I'm a recent graduate. I graduated like last December from Carnegie Mellon University, and I'm currently looking for full-time software engineers, particularly backend development, and I also use Java a lot.
Mm-hmm.
Uh,
Mm-hmm.
so yeah, so you
Great.
mentioned you're working on the Java backend technologies. So I'm guessing you're using Java servlets and the Spring framework, right?
Not exactly Java. Not exactly Java servlets because Spring generally abstracts out a bunch of things for you. So so yeah, it's it's Spring and related technology. So things have evolved, and I think Spring is gaining a lot of focus. So it's Spring, and then you'll have some backend. You'll have probably Hibernate to integrate with the backend to optimize on the database front.
Yeah.
And then if there's a real-time streaming requirement, you would integrate with Kafka or something like
Mm-hmm.
that.
Mm-hmm.
And then you'll have some kind of jobs which are doing kind of backend processing, which will optimize your real-time lookups, right?
Mm-hmm.
So that's the typical model that you'll find no matter where you go
I
in the
see.
backend world, right?
Oh,
But yeah, that's about it.
yeah, that sounds interesting. And
Great.
yeah, and since I'm a new grad, I don't have any working experience, so it's very hard for me to find a job. And recently, I've been practicing solving coding problems,
Mm-hmm.
and
Mm-hmm.
also learning full stack development on my own. I hope that
Mm-hmm.
helps. Yeah, that's about me.
Definitely. So I would suggest like since I mean, keep yourself open to full stack because I have seen that kind of trend, especially in the startups.
Mm-hmm.
So they are looking for full stack developers typically, when you're starting up. But if they're in case of bigger companies, it's a different scene. They have the clear distinction between a front end engineer, back end engineer, etc. So I think a new person joining, keep yourself open to learning the full stack, and then go along with how your career takes you basically.
Okay.
But yeah, that would be my 2 cents
Yeah.
to add
Yeah.
on.
Thank you for that.
Yeah, sure,
Mm-hmm.
definitely. So yeah, any other questions before we start?
Yeah, I think we can start.
Perfect. Okay, so are you familiar with this CoderPad kind of environment, like uh, are you
Yeah.
doing this for the first time?
I think I'm familiar with.
Okay.
I've used CodePad.io. I think if you're
Okay, yeah, it's similar to
yeah.
that. Yeah,
Yeah. Okay.
it's
Yeah.
similar to that. So, do you want to select your programming language of choice?
Yeah. I will select Java here.
Okay,
Uh.
perfect. And
Yeah.
then you can run it, and then it should run. Yeah, that's it.
Yes. Yes.
So yeah, so now let me copy the question over here.
Mhm.
Just a minute. I'll be pasting it in on line 5.
Okay. Okay. Okay.
So
I.
you're given a binary search tree. Are you
Mhm.
familiar with binary search tree?
Yes, I am.
Okay. So two of the elements in the binary search tree are swapped by mistake. So I want you to write a method which would take in a binary search tree and it would recover the tree without changing its structure, essentially.
Okay. Um. So, is there any duplicating the boundary search tree?
Um, for starters, let's assume that there isn't any.
Okay. Okay. Uh, so some elements are swapped, and it's a boundary search tree. So the left child must be less than the parent, and the right child must be greater than the parent.
Hmm.
Uh, would you mind giving me a few minutes to like sketch something on my paper to think this through?
Absolutely.
Yes, thank
Absolutely.
you. Thank you.
Sure.
Okay. Um, I think for these simple two examples, this is one example. For this simple example, I think uh, what I can think of immediately is that comparing like when we can like traverse, like for example pre-order traversal and look if element is like out of order, like you know, for example, if any like node uh, violates the invariant property, like for example here 3 is the
Hmm.
left child of 1. 3 is the
Hmm.
left child of 1, and the left child should be less than the parent, but here 3
Hmm.
is greater than the parent, so we
Hmm.
know that there's something wrong here. So
Hmm.
we can just swap them. uh, we
Hmm.
can just swap them, that becomes the answer of 312. But this is
Hmm.
trivial. I mean, this example is trivial.
Hmm.
Maybe something happened deep in the tree. How,
Hmm.
for example, maybe for example the tree is like two.
I'll paste a tree for you if you don't mind.
Okay, yeah,
So this
of
is the
course.
tree, say for example, right?
Okay, yeah. Yeah, like here, we can say that 2 is less than 4. That is correct. But 2 is actually one of the nodes in the right subtree of 3. so for binary search trees, all the nodes in the right subtree of a node should be greater than that if we don't have duplicates.
Mm-hmm.
So here
Mm-hmm.
two is less than that. We know something wrong with two, and we should swap two with three. So so to do this in algorithms, I think we can probably maintain a lower bound, the upper bound. And in the very beginning, the lower bound is minus infinity, and the upper bound is plus infinity.
Mm-hmm.
And we go left, which means let me just do it here. We go left. This is left. If we go left, the then we update our upper bound because the like left subtree is all the nodes should be less than the root. So our upper bound is 3, right?
Mm-hmm.
And oh, there is a typo. And if we go right, uh, the lower bound and upper bound should be 3 and plus infinity, right? And while we are updating our lower bound and upper bound, we're also checking if the invariant property is maintained. Like here, 1 is less than 3 is maintained, 4 is greater than 3 is maintained, and
Mm-hmm.
also we check if the nodes are within the bounds. So 1 is within minus infinity and 3, it's correct. 4 is
Mm-hmm.
within 3 and plus infinity, it's correct. And
Mm-hmm.
here 1 is the leaf node, so we stop there. So we go from 4, and since
Mm-hmm.
we only have the left child, so left. So we update our upper bound. So now the range should be 3 and no, no, 3 and 4, yeah.
Mm-hmm.
So that's lower bound, upper bound. And we check
Mm-hmm.
2 is less than 4, so the invariant property is maintained. However, 2 is not within this bound. That means something wrong with 2. So we
Mm-hmm.
kind of like lock this node here, and probably we want to, for a simple algorithm, we want to like do it again, like uh, so 2 is out of bound, and 2 is less than this bound. So we want so one way I can think of is to make 2 as the new lower bound. I mean, because 2 is less than the whole range, so we can make 2 the the new lower bound, and 4 as the original upper bound. So
Mm-hmm.
um so 3 should be here in this way. So we should look for the node 3 and swap it with this 2. So
Okay.
we go
Okay.
from the loop again. Yeah.
Okay. So are you maintaining a left and right for each node in this case?
Maintaining a left and right.
A left bound and right bound for each node in this case?
Yes, right.
Okay. So what will be the time complexity of this?
For this one, since we are visiting like every node, I think it's all
Hmm.
of them.
Okay. And how about the space complexity?
Since we are creating like this lower bound, upper bound favorite node, I think it's also all of them.
Okay. 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 So is there, so can you think of something that, wherein you don't need the space?
I don't need this all of them space.
Uh-huh.
Um, Well, I think we can make this range global or like an instance variable so that it's always that reference, right? It's always that range, the same range. It's changing every time we visit a new node. So it's always like all of one because it just have two elements and every node is using the same range. It's just the values of the range changes every time we visit a new node. So in that case, I think the space complexity will be O of log n, where the height. I'm sorry, because sometimes the tree may be unbalanced. So the space complexity is the recursion depth of our algorithm. So yeah, so with that we can reduce the space complexity to O of h.
Okay. 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 So why don't we get started with the solution and then we can go the other details later.
Uh, yeah, well, I'm not sure if this algorithm is correct because I haven't fully proved it. I just feel like maybe it works. Is it still okay to write the code now?
Well, I don't know what why do you think it might not work? So in case you maintain a left and right bound per node, why do you think it might not work still?
I don't know. I just have that gut feeling, but
Okay, okay.
yeah, but I think this should work, right? Because if this is out of the range, we just check if less than the range or more it's greater than the range, and we like uh replace the corresponding bound and
Hmm.
swap that bound with this node. So let me implement this algorithm and see if
Hmm.
works. Uh, so let me delete these things here. And um, let's assume we already have this node data structure and it has left and right pointer or reference. Um, and we should mm, call this method maybe recover BST. And we're giving a root node. Okay. Um, and we maintain a range at the global variable instance variable, which is the int range is integer minus infinity as lower bound initially,
Hmm.
integer max value as upper bound. Okay, so if root is null, just return. Okay. Otherwise, well, maybe we should. Okay, if root is now returned, then we go to our helper because we need to also maintain the parent reference here. So we go to our helper with our parent as log in this case, and our root is our root. Our private void helper load parent and load current. Okay. Um, so okay, so we need to check if this maintains the invariant property. So if p is not long, uh, then we need to check um, if the we need to check it's the if this current node is the uh, is the left child or the right child of P. So if um, it's the left child, if C is the P is left child, and C dot val is actually greater than P dot val. Uh, okay, so here we're accessing its member. So probably C is no, so we need to exclude that if C is no.
Hmm.
Return. Yeah, and so if this is the case, we need to swap these two nodes. Uh, swap these two nodes. Let me just call a swap function here.
Hmm.
Actually, we don't have to do. We can just do it right. Okay, just swap. Okay, let me just write it down. So we can do a temp. No, we can just so we should swap it. Uh, how can we spend? Can you give me a minute to like draw a tree? Maybe I'm kind of confused here.
Yes, sure, sure.
Yeah. Okay. Um, Yeah, we're missing a parents reference, right? Because if we
Yes.
move our current load up, we need to kind of like
That,
uh make the parents like a child reference pointing to the current reference. So we're missing that.
yeah.
So let me just write a function, and
Mm-hmm.
can I handle them? We can focus on this later. Um,
Mm-hmm.
so C and P, and we should implement this, and we can return here. Um, we can okay, we can return boolean. That means we have already recovered the tree, so we don't have to go any deeper. So return true. Um, so if it's the left child, and if the current value is less than the parent value, then we can swap C and P again. It's the same here. And to implement return true. Okay. If now the invariant property is maintained, and we need to check if it's if the current node is uh, if the current node within the within the bound. Uh,
Mm-hmm.
yeah, actually, let me just put the dot val and the p dot val. We just pass dot val p dot val to this swap because we can just use the integer like integer to find the node to make it
Mm-hmm.
simple. Yeah.
Mm-hmm.
Okay. Here, let me check if it's within the bound. If it's not within, if c dot val is less than the lower bound range 0, then we can just swap c dot val with um, the lower bound and return true. If c dot val is greater than the upper bound, then we replace the upper bound with our current value. Swap c dot val with range 1. I'm sorry, typo here.
Mm-hmm.
So and return true. Okay, and so after all these are done, we know the property is maintained, and it's within the range. So the problem is not here. We probably should go deeper. So we can check both the right and left child. Here we just return true, maybe return false because it's
Mm-hmm.
not swapped here. Um, okay, we can go to the right and left. Um, if helper uh, see, but before go to right, uh, before go to right, we need to like change the range. We need to change it to, if we go right, we need to update the upper bound. So our we need to maintain the old. So we want to like like update it back because it's like instance variable. It has a state. It's not stateless. So it
Mm-hmm.
needs old is the same as range 0, range 1, and we need to update our range to our range 1 to current val, and we can do this now. So the parent now is C, and the child now is C dot left. If this is if we have fixed it here, we can return true without going to the right. But otherwise, we need to change it back to the original val, which is O dot 0. Okay, and we
Hmm.
can now if we go right, we should update our lower bound. So we should make range 0 to make range 0 our current dot val. Okay, and and we can do our right, our if our right is right, our right should be helper. uh, um, so the parent is again is C, and the child is C dot right. And before we return, we need to update it back to its original range. So range 0 is made back to its original range, and we can safely return here. Turn right. Okay. Yeah. So there, we're done with this helper method. Uh, we can go ahead and implement our swap method.
Hmm.
Our swap method void swap. Okay. Our value 1 and value 2. Okay, we can swap them. Um, so if we want to swap them,
So this is going recursively, right? Basically.
yeah,
Okay.
we
Okay.
probably want to find both of their parents, right?
Hmm. Okay.
And
Yeah, just trying to
uh,
understand. Yeah, that's fine. That's fine. You can go
yeah,
ahead. Proceed ahead.
want to find their parents, and we want to know which node is actually deeper. Uh, like
Right.
I don't know, like node 1 is here, and node 2 is somewhere here, and node 1 has a parent maybe. Um, like this.
Hmm.
Node 2 is down here, so we should can I just update the value without like rearranging the references? Is that okay? Or I have to like rearrange the reference, make p dot right equals n2, or I can just change n1 dot val to be like
How does
n2
that
dot
simplify
val.
your algorithm?
If I do this, uh, I actually don't have to find the parents' references. I can just modify the values, and
Hmm.
that's much simpler. If that's
Yeah,
okay, I
I
can
think
do
that's
that.
fine. That's a fair thing.
Okay. So
Yeah.
first of
Because if you
all, we
read the
need
question,
to.
I say recover the tree without changing its structure. So I don't expect the structure to change. Uh,
So
so
yeah,
I mean, changing the value should be fine, basically.
yeah, that's good. So changing the value, first of all, we need to find these two nodes. Uh, Let me get node. Yeah, we need a root as well because we need a root. Let me just put our root as a global variable for simplicity. So load root is here should be this dot root is root. Okay, so this is made simpler. Otherwise, I have to pass root to these methods.
Yeah.
Okay, so we can find load 1 and load 2. Uh, Find node 1 and node 2. Let me from node 1 to root dot val. Well, um, well something, I don't know. Uh, so um, So okay, so while n1 dot val is not a one, if b1 value is less than n1 dot val, then we should go left. Should go left. Or go left. So n1 is n1 dot left. Else if v1 is greater than v1 dot val, we should go left. Uh, n1 is equal to n1 dot right. Okay, and else if they're otherwise if they're the same, the v1 is less than v1. Okay, I think this works. Yeah, and we need to do the same for for v2. So for modularity, we just make a function or make a method here called find node. Uh, find node given the value v, and copy the node here. Node. Okay. Let me get rid of this one and okay, and we can return this node. Well, n is not long, and we can return it. Okay, then we can find node n1 is find node a1, node n2 is find node v2, and we can swap them. Temp is n1 dot val, and n1 dot val is now n2 dot val, and n2 dot val is temp. And we're done with the swap method.
Okay.
Yeah, I think I'm done with this.
Okay.
With this
Perfect. Let's
algorithm.
test it out. Let's test it out.
Yes. Yeah. Okay, let's test with the last example, shall we?
Yeah, sure.
Yeah, so the root is 3. And we call this recover BST method passing 3 here. And 3 is not allowed. 3 is not allowed, so this so we don't return. And root is 3,
Oh,
and we
so
go to help.
do you mind writing a tree and then building a tree and then passing that root so that we can run and see?
Okay, cool. Yeah, sure. Let me just write the class private static class node. We have left and right, and we have val. We can do a constructor with val and make our val equal to v. So we can build our tree in the main method. Root build tree. So build tree. Tree is yeah, we can do it there. Root build tree. Okay, we can do private static node build tree. Okay, node root is new node 3, right?
Mhm.
And our root dot left is a new node 1, and our root dot right is a new node 4, and root dot right dot left is our new node, which is 2, right? Okay, I'll return root. Um, okay. Um, okay. Then shall we do a in order, like in order print, so
Mhm.
we can know what the in order traversal is like. So let me do it here. Okay. Private static void print in order, given the root, if root is long, return. Otherwise, we go left first, print left root left. Then we print it. System dot out dot print 9 root dot down. Then we go to right. Okay. And after we build this tree, we have a solution object, and we recover our BST with our root. Oh, let me just print in order first without um, recovering it. So, and system that out that print 9, giving it a empty space. Do it again here. Okay. Shall we run it? Yeah,
Did you?
we can. Oh, line 149. What is it? Oh, no, private voice swap 115 is illegal start expression. Illegal start. Why is it illegal start expression? Have void here.
Why is it illegal?
Maybe the matching of the braces, I guess.
Yeah, probably that is the reason. You have
Okay.
here, you have there, you have this thing, you have this thing. Oh yeah, so there's one more parenthesis required. I just added. Okay,
Okay. One. Oh, lot of lot of
that's
errors.
fine.
Sorry
That
about that.
happens. That happens.
Uh,
That happens.
yeah. Okay. Nodes. And 129 is v dot val. It should be n dot val, right? If v is yeah, let me run it again. 114 missing some return statement. Uh, what am I missing here? Oh, it should be here actually. I should delete this.
Oh, okay.
Null pointer exception 134. uh, our swap is null pointer. So so our find node will actually return allow load.
Mm-hmm.
Why is that? Uh, for this example, we should swap 2 and 3. Um, so let me print what we're finding here. Just print it. We're finding 2 and 3. Yeah, that should be correct. Why is it? Uh, and 3 is no. Okay, now 3 is the root, so we just return the root. 2 is not the root. Oh, right, because it's you know it's not the right structure because we that's what we need to do. So we shouldn't depend on the in order to in the invariant property to find the node. So yeah, so we shouldn't do that.
Mm-hmm.
Um, so mm, so instead of doing that, I'm gonna uh, I'm gonna make the range of two nodes actually, two nodes instead of two integer value. So we can just so when we meet the problem, we can just swap it right there. You know,
Mm-hmm.
so node. Okay. With this, we go to our helper method. Where is our helper method? Here. Um, yeah. So instead of swap, we just change the value of two nodes. We just do C and P, and our swap here is just two nodes, node N1 and node N2. We don't need to define node method.
Mm-hmm.
We can just do temp N1.val and N1.val is N2.val and N2.val is temp. Okay. We can swap here and swap here, and we can swap here range 0.val. Can swap here there dot val. Okay, and here our node is still two nodes, range 0 and range 1, and mm, range 1 should be C now, and range 0 should be C. Yeah, we make it back. Okay. Yeah, I think we can run it now. Yeah, then we can fix this specific tree. Not sure if we can fix other trees, but this one we can fix.
Okay. So what will be the time complexity of this now?
Now the time complexity is still OFM because we have to, in the worst case, we
Okay.
have to visit every node.
And how about the space complexity?
It's still of the height because we don't have extra memory. We have constant extra memory. So yeah.
O of height. Okay. Why won't it be O of n?
Um,
Because you're doing
because
recursion and each node would have a stack entry. Isn't that right?
yeah, that's the stack space. So yeah, we're not creating other collections. So Yeah, so memory comes from the recursion, the memory
Right.
usage.
So how much of memory would be there on the stack? The total consumption on stack.
How much memory? Uh, how much memory should be on the stack? What do you mean by that? Do you mean the limit, the upper cap, or
No, sorry. So how much of stack memory usage would be there in this code?
in this code? I think it's all of high. I mean, we're creating this to node, this old nodes here, but
Mm-hmm.
it comes with every helper, and uh, when we reach the leaf we and return, we actually pop that stack, and this old is also gone. So I mean, in the same time at maximum, so there are like the height the height olds that many, that many olds here.
Okay.
uh
Okay.
yeah.
Got it. Got it.
So
Uh, okay. I think we have reached the time to, and it's a working solution. So that's good. So that's it about the coding on the coding round. So let's move out of it. We can run a few more test cases probably, but we can do that later. But I think this is fine. Um, okay, so coming out of this question, so what did you feel about the question?
what I'm sorry.
What did you feel about the question? So what was your thought process? Was it a easy one? Was it a hard one? Or was there some trick in the thing?
Oh,
What was your
I
take
think
on the question?
I think the difficulty level is medium.
Uh-huh.
It's not very easy because it's sometimes this you cannot like know the answer immediately. You have to like like experiment, and it's easy to ignore the upper bound, lower bound, and just look at the invariant property. So I would say it's medium. Yeah, medium difficult.
Okay, got it. Okay, great. And before I share my thoughts on the on your round, do you have any feedback for me?
Feedback for you as an
Feel
interviewer?
in general, like the way the interview went, and could I have been more clear in some aspects? If you don't have it at the top of your head, that's fine. You can always document it later and send across. But I just wanted to know.
Oh, well, I think you're pretty good as a interviewer, and you give me the sample input and sample output.
Mhm.
Uh, so yeah, so
Okay,
I
that's
think
fine. If you don't
you're
have
good.
anything, that's fine. That's fine.
Well,
Great.
but but I'm wondering when I have come up with this solution, did you know it was correct or wrong, or you didn't know
Well, it
either?
was no. So all I wanted to see was how does it impact the space complexity. So from my side, that was because initially, if you remember, you started with having a bound stored at each node, right?
Mhm.
And then
Mhm.
that would have added a fair bit of complexity, right? Now,
Mhm.
because you are using stack, okay, I'll come to my feedback, right? So your solution is optimal in terms of if you remove the stack aspect of the solution, it seems to be optimal. Okay, there are different ways to solve this
Okay.
problem, basically. But because of the stack, if you see, it's there's also a extra load of uh, creating the stack, putting all the local variables into it, then
Mhm.
offloading the stack, right? So that's the additional work that the CPU has to do. Now, of course, the CPUs are very powerful right now, but if you think of a very large binary search tree, right, wherein just
Mhm.
two members are swapped, right? So this may or may not work basically in that case. I mean, because of the
Okay.
amount of storage that could go into the stack at that point in time. So there are different ways,
Yeah.
as I mentioned. So one of the ways, so you yourself printed as an in order tree, right? So the simplistic solution could have been like you do a in order traversal, you find out the two values which are out of place, and you just swap that, right?
Oh, yeah. That's
I mean,
yeah, yeah, yeah.
that would
That's
avoid
very
a
straightforward.
lot of yeah,
Oh
that would
yeah.
avoid a lot of your code that you have written over here. Happy that the code worked, because as an interviewer, what I'm looking at the end of the interview, and what most of the interviewers look in a telephonic screen, is you should have a running code, right? It should
Uh-huh.
run against the input, because that is very important. Even if it is
Mhm.
suboptimal, if you have a thorough understanding of what are the pain points in your code, and you have a working code, you know what your time complexity and space complexity is, and even if you have a slight
Mhm.
hint of the a way to optimize it, I think people
Mhm.
would be pretty happy, or at least give you another opportunity by putting into a second round of telephonic screen, right? But
Okay.
that is very important, I feel so, because we are not talking face to face, right? So I don't know, like,
Mhm.
what you're up to over there. So at the end of the thing, if you have something running, actually that gives me confidence that, okay, and you're debug something, while you're running it, and then that gives me confidence that, okay, you have gone through that process, you have a code that is running right now, right?
Mhm.
So which is
Yeah.
good.
Okay.
Overall, I would, so if it were to me, I think I would, it would be a leaning yes for me, in the sense that if there was a prior interview which was also a leaning yes, then that's a good thing for you. But if you may have been selected for another round of telephonic screen or called on site, right? So that would have been my state, if I were to speak with you. Of course, there's a missing component in my interview, which is like going through your projects and seeing what kind of exposure you have in terms of technical skills. So that's a
Mhm.
part. I would have tested on a few Java skills, say data structures, etc.,
Mhm.
which it's not a part of this mock interview, but expect that from the interviewers too. So it would have been that whole thing together would have consolidated my feedback in your case. But I think this is a decent working solution, I think so. And it's good that you could do it from end to end, in terms of writing the inputs, writing the test cases, and then executing it, right? So that's a good thing that came out of this interview.
Okay. Okay. Thank you so much.
Sure.
So if
And
you were go ahead. I'm sorry.
yeah, I'm done. You were saying?
Okay. I was just wondering if you were interviewing me for real, would you pass me for the on-site or the next round?
Yeah, so that's what I mentioned. So there is a small piece of your project work, and because I don't have it's a anonymous interview, right? So I don't go through that part, but I would have spent
Okay.
some time on that, and based on that and this coding itself, I would have decided. But if it were to just limit to this coding, I think I would pass you.
And how was my communication skills? Did I speak clearly?
Yes.
Did you
So
understand me?
right. So, coming to that part, so that's another point that I noted. I think you have to be a little more vocal of your thought process. There's a moment of silence that goes through, right, intermediately, which is fine. Like, you have already communicated to me that give me 2 minutes, I'm thinking about it, etc. But
Mm-hmm.
especially doing the technical phone screens, right? It's better to uh, just do a ping in between, like talk out aloud what your thought process is, because we don't know what you're up to over there, right? If it is a face to face interview, then that moment of silence is fine, because you are in front of me and I know that you're thinking on something, right? But it's
Oh,
always good to not have a prolonged moment of silence when you are thinking.
so even if I'm thinking uh and drawing something on my paper, I should say that I should say my
uh,
thoughts and not
Yes,
about right.
I'm not saying about a running commentary of your work, but you can at least, in between say that, okay, these are the aspects. I'm just thinking about the left bound. How will I do, or something of that sort, so that at least I know that, okay, this is the way you're focusing on. This is the direction which you're focusing on. Or I'm thinking about recursion. Say for example, I didn't know that you are going to go the recursion route until I saw it in the code. Say for example here, though I'm sure you would have thought about it at some point in time, etc. So, so these are some of the trivial things, basically.
Okay, I see, I see. Yeah, those are very valuable things. Thank you.
Sure. Great. Well, that's it from my side. I will also document a couple. I think I spoke a couple of points in terms of feedback, so I'll document that and I'll submit. And if you have any other, if you don't have any other questions, then we can end the interview. Or feel free to ask
Oh,
me if you have.
yeah, yeah. Can I ask you maybe just the one last question before you go? Uh,
Yeah, sure.
so, um, so did you actually prepare just one question, this question, or did you actually have a follow up or another question after this one for this interview?
Well, I would have optimized basically because I don't like using stacks because of the
Yeah.
thing on the stack aspect
I
because
see.
that has a bunch of its own problems.
Mhm.
As I mentioned, there are various simplistic approaches too, right? So I would have loved to
Mm.
discuss on the pros and cons of those approaches versus the approach that you suggested,
Oh,
right? So
okay. Okay.
in case of say having an in-order traversal and then swapping two values, your time space complexity would have been O of n because you would create that array, right? Basically of n elements, and then you
Mhm.
would swap, right? There are certain discussions that I could have done, but that's like a add-on bonus. But again, that's what I would say. The 20% of it, the 80% of it is the code, and the 20% of
Mm.
it comprises of the optimizations and your project experiences, your know-how of the technology. So so all those discussions comprise of this 20% for me at least. I'm not sure about the other interviewers, but certain interviewers they just come in, they'll give you two problems, just solve it, and that's it, done. So if you run both the things, you are done. So I have
Mm.
seen a variety of things that people do in today's job market.
Okay. Okay. I see.
Yeah, yeah.
Yeah. See. Yeah.
And some
Thank
may
you.
not
That's
even talk. I think I spoke a little bit during the. We had a good interaction throughout the interview, but do not expect that with everyone. Some of the interviewers keep to. I mean, um, keep quiet basically throughout the interview. So you may not
okay.
get too much of insights or anything, which is fine. I mean, but that's their interviewing style. But keep in mind about that too. Like it can be a
Okay.
one-sided one, so wherein they're just expecting you to write the code and run it. So some of the
Yeah.
startups, especially, yeah,
Yeah. I see. I see. Yeah. Right.
yeah,
Mm.
great. So that's all.
Mhm. Yeah.
Yeah,
Okay.
did you
Thank.
have any other
Thank you so
questions?
much.
Okay,
Sorry.
okay,
What's that?
perfect. Did you have any other questions?
Did I? I'm sorry. I didn't. I didn't catch that.
Sorry, did you have any other questions?
Oh no, no. Thank you so much for. I mean,
Okay,
you
perfect.
answered my
Sure.
questions. Yeah.
Yeah, definitely. So good luck with your preparations. Yeah.
Thank you. Thank you so much.
Yeah. Bye.
Yeah. Have a good day. Bye.
You too. Bye.